This is Mario with MIA Microflight, and in this video I'll be talking a little bit about the three different types of 3D printers that I have here. This is a conventional Cartesian 3D printer. This is by Monoprice. I believe this is called the Mini 10 Pro, which is a 200 by 200 by a little bit over 200 in height 3D printer, Cartesian style, meaning the y-axis is this way, the x-axis is built on the gantry here, and the z-axis is the gantry rising up and down. This one right here is my own design, is a CoreXY, basically your typical CoreXY with the motor's location at the back at the corners here. So, belt driven in an XY configuration. This machine uses non-standard linear rails. These are carbon rods. They run on 3D printed guides or bearings. You can see these are bushings, and so that's how this machine was designed, just for simplicity and to keep everything lightweight. I did not want to use the metal linear ball bearing type rails that are typically employed on most machines, including some of these Cartesians. This one runs on rollers, and it's typical of the Creality Ender 3, Creality CR10, and some of the similar machines that came out after the machine was done. The Anycubic i3 Mega, which I don't have here, which is one of my favorite machines. I have several of those. Those run on the linear rails that have ball bearings, recirculating ball bearings in a tubular package, and so that's how those rails run on those machines. And so I did not want to use those here because of the weight, because it starts getting really heavy, and I wanted to keep this as light as possible. In particular, the head assembly here, which also runs on carbon rods with the PLA bushings here, it's very, very smooth, because you're not running this at very high speeds that are going to melt the plastic. This is quite doable this way, and so this is my MIA Wink. I call this one the Wink. And you can see the table on this one is driven by a belt drive system on dual belt drive, which runs in tandem. Both Z-axis motors, I should say, operate the bed. The bed is not heated. This is my own bed as well. It's a phenolic material. I have some videos that talks about that. I use phenolic sheets here for the for printing PLA and some of the easier materials to print with. I have not tried any other materials other than PLA and PETG. So I don't know how that would work with other materials. I'm sure this would work if this was heated, but it's not a heated bed as it stands right now. Next to this machine is the MIA Blink, not to be confused with the Wink. This is the Wink, very similar on naming, sounding, but this is called the Blink. You can see the name is right on the head assembly here. This particular machine is very unique in the sense that it rethinks the motor locations to these locations here. Is in the center of the complete XY assembly, and not on the sides, or rather on the ends at the corners. Is 99.9% of the CoreXY machines are done. In fact, I would say all of the CoreXY machines are done this way. There's no machine, at least not up to this point, that has relocated the motors as I have relocated on this machine here. And the reason I did that is because I wanted to maintain the whole assembly as working in all three axes, the X, Y, and also the Z axis. So this rises as the part gets built, from the bottom up. It rises up and it does all the movement. And the idea behind this, as I explained in some other video, is if you take a pencil and piece of paper, your paper is steady on the table, and your pencil is the one that's doing all the up and down and moving doing the writing, making all the XY movements and the Z movements. And so that concept came to mind when I did this machine, and I wanted the same approach in a 3D printer. And so this is how it came up with this machine. And I also wanted the motors to be at the center in symmetry as part of the XY frame assembly. So this is the frame. This machine is done with 10 millimeter square extrusions that I bought from Amazon. I bought all of the extrusions that they had in the 300 millimeter lengths. They do have some other ones in longer lengths. I don't know if they have restock as of today. We are December, I believe today is December the 15th. So I hope the company restocks, this particular extrusion, because I can do a lot of things with this particular size. It's a very nice size, kind of non-standard, because most of the 3D printers are done with 2020 extrusions or something similar to these extrusions that I use here. I think these are 20. These are 2020 extrusions here. They also have 1515 extrusions, but this one is done in 10 millimeter square extrusions. So that's my. This is my machine, the MIA Blink, non-standard or non-conventional CoreXY machine. The bed, I have yet to finish this. This needs some thermistors and some LEDs to complete that the hot bed, and then this has to be mounted on a frame. This is going to be steady as part of the base here, and all the connections are going to be on the side of the machine with a separate power supply unit and control as one unit that's going to be separate from the machine, so the machine is going to remain very clean here. I have some other things that I've been working on. That's why this machine is it's a little cluttered here with some other items, but this is the machine, the MIA Blink. And I've done some short videos on this, various short videos, to that illustrate, the how this machine works. And I did some sample runs on this machine already, and you can see those in my shorts on my YouTube channel. Check those out. The rail system here is also my own design. These are the carriage blocks. They run on Teflon inserts, and the Teflon inserts are running directly over the anodized extrusion here, so it's very, very smooth. It moves very precise and very smooth, and there's no play whatsoever. But just in case I need to adjust, I introduce these screws here. These are nylon screws, or no, not nylon screws. These are actually metal screws that push on the inserts, on the Teflon inserts, in case I need to further adjust, for a little more precision. But as they stand, I haven't had to do that on this machine yet. I mean, I inserted the linear or the Teflon inserts, and it was pretty precise to begin with. But these screws are there for the future, in case I need to make further adjustments. All the XYZ axis run on the same type of rails here, linear rails. They run over these, as I said, aluminum anodized extrusions. So it's very simple, very lightweight. This machine will speed up quite quick, which I will show that in a later video when the machine is all finished. I have yet to connect the hot end here, make all these connections. Right now I just have it connected, borrowing the control system for this machine, which uses a Ramps 1.4 controller. And so right now it's not fully connected, but I have done some tests on this machine already. So this is my non-conventional CoreXY machine with the motors at a new location here that I have not seen this done up to this point, or up to when I started making these videos. and I searched high and low for similar machines, with the motors as you see them here, and I did not find any. So this is the first one, perhaps, in the world. This is Mario with the Maya Micro Flight. Stay tuned for more. Please be sure to watch all my shorts and go to my YouTube channel and check out the stuff that I've been posting there lately. Thank you.